Pythagoras' theorem involves right-angled triangles. If we have a right-angled triangle with sides A, B and C, where A is the hypotenuse, side opposite the right angle is the biggest side, we memorise Pythagoras' theorem as A squared equals B squared plus C squared. Here W is the hypotenuse, it's opposite the right angle. W squared equals 12 squared plus 7 squared. Follow that through, 12, 12, 7 sevens, add them together. W squared is 193. To get W on the calculator, square root 193. Write down the answer. It's not an exact answer. Round appropriately. W is approximately 13.9. So that's for the hypotenuse, square and add. If you want a shorter side, as in this case, 15 is the longest side, it's opposite the right angle. P is a shorter side. P squared plus 7 squared make up the 15 squared. To solve this equation, take 7 squared off each side, and P squared is 15 squared minus 7 squared. If you memorise that for a shorter side, you square and subtract, you can skip the first line, follow that through, 15 15s and 7 7s. P is the square root of 176. Write the answer off the calculator and round as appropriate. So that's for a shorter side, square and subtract. We're going to apply Pythagoras' theorem to 3D shapes. So this is a cuboid. Face diagonal is a line joining opposite corners on one of the rectangles, like from A to C, or E to G, which would be the same size, or H to F, or G to B, and so on. There's a face diagonal AC. Together with side AB and side BC, you make a right angled triangle. You can apply Pythagoras. A space diagonal joins opposite corners in the cuboid, like A to G, so it passes right through the cuboid. Equally, it could be from H to B or E to C. These space diagonals will all be the same size. There's the space diagonal AG. It's a hypotenuse of a right angled triangle, where one of the sides is face diagonal AC and side CG. So Pythagoras will apply to this. AC is a face diagonal with sides AB and BC of the cuboid. So in this example, you have to calculate the length of space diagonal AG. So first, there's this blue right angled triangle where AG is a hypotenuse. One of the sides is 40, but we don't know AC. It's a face diagonal. We need to calculate it. We can calculate it using the triangle ABC. AB is 24, BC is 18. Hypotenuse AC can be calculated, and then we can use the blue triangle to work out the space diagonal. So it's two uses of Pythagoras. There's the face diagonal, the sides 24 and 18. AC is the hypotenuse opposite the right angle. AC squared is 24 squared plus 18 squared. 24 24s and 18 18s. Follow it through, AC is 30. There's AC is 30. On the blue triangle there's AC, it's 30. To work out AG, the hypotenuse, AG squared is 40 squared plus 30 squared. Follow that through, and AG is 50 units long. That's a face diagonal and a space diagonal. So we're calculating the size of the space diagonal. This is harder, it's a pyramid, square-based pyramid. And we want to calculate the height. So you have to spot where right angled triangles could be involved. There's a height, the black dotted line, EM, makes a right angle with the line MP. MP is half a side, it's half of that 4. this line, EP, runs from this corner to the midpoint of BC, and it makes a right angle here with BC, and there's a triangle on the right side here, EPC. Now PC is also 2 because it's half of the side 4. EC is 4 because it's the same as that 4. So if we apply that, there's EPC, right angle triangle, sloping edge 4. PC is 2, half of a side. EP is a short side, EP squared equals 4 squared minus 2 squared. Follow that through, and EP is the square root of 12. Won't work that out in the calculator because we're going to reuse it. What we've now got is EP is square root 12, we know MP is 2, and we want to know the black dotted line. So if we take the triangle EMP, the height is EM, EP we just worked out at root 12, and MP was half a side, 2 units. EM's a shorter side, it's EM squared is root 12 squared minus 2 squared. Now if you take a number and you square root it, and then you square it, you go back to the original number. So root 12 squared is 12, 2 squared is 4, EM squared is 8, and EM is the square root of 8. You can leave it like that as an exact answer, square root 8, or in the calculator, write the answer down, round it off as appropriate. EM's 2.8. Now that's the best way to do this question. I'm going to show you another method which is not as good but still works. So in this case, we draw in a line AC, this face diagonal. It halves to AM. We know the sloping edge is 4, and we want to work out the height EM. So this right angle triangle is to be used, but first we must know AC, so we can half it for AM. Well, AC is a face diagonal, and the sides 4 and 4, well, along with AC, make up a right angle triangle. There it is, AC squared equals 4 squared plus 4 squared. Follow that through, AC square root 32. Now we want to half that, that's a problem. We want to half a square root. What you could do is quarter the number inside the root, which would be 8, and half of root 32 is root 8. A quarter of 32 is 8. Now, otherwise you would need to use a calculator. Get root 32, half that, don't round it, it's 2.828 with a lot of figures falling. If you round it, you'll introduce an error. That is actually square root 8. Now, if you go to the triangle EAM, it's got a right angle, hypotenuse is 4. This was half of root 32, approximately 2.8, but we won't use 2.8 because it's rounded. It will lead to an error if you squared 2.8. So EM squared is 4 squared minus this unrounded 2.8. Now as long as you use that unrounded, it will square root 8, which will become 8, exactly 8. If it's not exactly 8, you've introduced an error by rounding. Follow that through, EM's the square root of 8. There it is off the calculator, there it is rounded. It's the same answer as before, but that's a harder way to do it. I don't suggest you do that method, but you do the previous method. Not getting root 12 in the calculator, but reusing it so it goes to exactly 12 when you square. So there's a worksheet on space diagonals which you can download using the link in the description, and it will give the answers. And it also has pyramids. So you can either download the worksheet with the answers or freeze the video to do the questions. Here's the second part of the worksheet. Here are the answers. These are exact answers and no rounding involved. Here are the answers to the second part of the worksheet. This answer to question 8 is exactly 7. You can download the worksheet from the link in the description, and it will also give the answers. You can also download a set of notes for all the Pythagoras' theorem videos. The next and final video will be on the converse of Pythagoras' theorem. Hope you found this video useful. Thank you.